Okay. Sometimes we have systems of equations, and we want to use the substitution method to solve. Uh, One of the way we frequently use the substitution method in physics, simply because our equations don't always work out quite as nicely to use the elimination method. So substitution method is important to understand. And first step in the substitution method is pick a variable to isolate. And for simplicity's sake, let's isolate this positive y variable over here. And if we isolate that, we are adding 4x to both sides of our equation. And that cancels that out. You're left with y equals 6 plus 4x. And if we have 6 plus 4x, y equals 6 plus 4x, we can take this here and we can plug that in for y. And we would get negative 5x minus whatever y is equal to. We'll put that in parentheses, minus 6 plus 4x equals 21. So negative 5x, and now we'll distribute the negative through the parentheses. That tells us that's negative 6 and minus 4x. That all equals 21. Now we add our like terms. We would add 6 to both sides. That would give us 27 on this side of the equation. And add the x terms together. That tells us that we have negative 9x on this side. Divide both sides by negative 9. You'll get x is equal to negative 3. Now, to figure out what y is, just take what you got here and plug it in for x. So that tells us that y is equal to 6 plus 4x. We now know what x is. X is negative 3. That'll give us a negative 12 plus 6. Y is going to be equal to negative 6. Because this is negative 12. This is 6. 6 minus 12, negative 6. Okay, we'll try one more practice. Okay, here we have a system of equations where we're going to do another substitution method. You can see that the elimination method would be fairly difficult to do with this problem. I need to multiply through by a fraction or whatever. So let's solve this using the substitution method. One of the things we want to do is isolate a variable, so it looks like x in this equation here will be pretty easy to isolate. If I divide everything by a negative 2, if I divide everything by negative 2, I'm left with x minus 3y equals negative 3. And then I'd add 3y to both sides to isolate my x variable. And I get 3y minus 3. Just to back up, if you don't divide by, if your first step is not dividing by -2, but adding or subtracting the 6y over, and then dividing by a -2 from both sides, you're going to come up with the same answer. Okay, so this is what x is equal to. And we take that, and we're going to plug that in for x in our other equation, and we get -7 times -7 times 3y minus 3 plus 8y equals -5. Let's multiply through by the -7. -7 times 3y is -21y. -7 times -3 is plus 21. Now we combine our like terms, and we get -13y on this side, and subtract 21 from both sides gives you a -26 on this side, leaving you with y equal to 2. And we take this, and we can plug it in for our y, and we can say that x is equal to 3 times y, which is, we now know is 2, minus 3 tells us that x is equal to 3.